Thanks for the introduction, and thanks for having us.
Super cool.
It's a great pleasure, Amit, to be here with you, chatting. The time that I started as an academic, you were transitioning to the industry. I also took that path. Now I'm back. And so very happy to be here discussing some stuff with you.
Congrats on all your success as well.
Thank you.
Looking forward.
Yeah, so the structure that we have in mind here is going to be much more informal than the previous talks. Right? So it's going to be like the two of us chatting. And since both of us have been in academia, then in industry, I thought the first thing that is very interesting for me to discuss, to bring it up, it is about the differences of causal inference tools that we see in academia versus those we see in tech industry. And we have been here the whole day today, talking about causal graphs, selection, observables, econometrics, and so on and so forth. And in my experience in the last 2 years that I spent in tech, it is that usually we always start from that word. Right? So we always start having we have a theory, we have some data that we want to account for, and once we select the variables that we think is important, we're going to deploy some kind of selection on observables techniques, I don't know, matching if you are some old school, inverse probability weighting if you don't want to model the outcome of interest, or if you go to the more modern world, you're going to do some kind of double machine learning. And in my view, Amit, in the last year, I have been seeing this everywhere I go. On the other side, in academia, there seems to be a big discount on studies that focus, put a lot of emphasis on observational tools, kind of unconfounded selection observables. And I find that very, very interesting. Right? So this is the first observation I would like to make. It is that, at least in tech, as a starting point, even though imperfect, very often we deploy tools that based on selection observables, ruling out unobserved confounders. And in academia, you don't see that at least as the first stage. In economics, that happens so much.
Yeah,
right?
No, totally agree. And I think it's really interesting when we think about causality in this conference. By the way, Darko, congratulations, this awesome event. And I was telling him earlier, I feel like I'm at a Hollywood premiere here, but it's a Causal AI Conference. Look, we just heard finance, applications of causal reasoning to making financial decisions. Technology companies, very interesting parallels. Tech companies are in the business of building products, right? So we're building technology, services, cloud infrastructure, and at the core of it is this causal question, right? If we build X, what's going to happen to the business, right? What's the outcome on customers, on product metrics, shareholders, complicated set of stakeholders. So, first off, as Pedro mentioned, causal questions are first order in tech firms. Other part, though, as Pedro mentioned, there's a ton of data. These companies are swimming in data. We have more data than we know how to ingest, how to process. And so, academics, and I come from, we both span these worlds. A lot of these methods, what our preceding talk even mentioned, they were born in very data-poor environments. It's sort of, we observe a couple things. Most of it is in the unobservable. Most of it is in the error term in the regression. It's not really in the things that we actually observe and control. And I just think, with technology companies, we have lots of X's. And so it makes a lot of sense.
Yeah.
What is the problem of causality? Is there's some spurious correlation. There's some unobservable. What is the best way to control for an unobservable? Make it observable. Observe the thing, proxy for it, matching, inverse probability weighting, sort of a whole host of techniques. And it just makes sense from an evolutionary perspective to kind of start with data, correlations. You want to see, can I trust these correlations? If you want to stress test them, start controlling for things. And I think tech firms, being much more practical, have to sort of think in those terms. That being said, I think there's a lot of value in thinking hard about unobservables, because even if you think you've observed all the X's and we have the right specification, we have the right DAG, thinking about what could be wrong with it, which is really where the academic mindset shines, really forces you to discipline how you think about the mechanism. You probably don't have it right. Very few people get it right. Why might it be wrong is sometimes just as interesting as why might it be right.
No, I agree 100%. Everything, Amit, is like, it's true. There is so much data, right? There is so much stuff going on. And I mean, even when you have a DAG, so still everything is observable. We have to match that kind of like, the DAG gives you the identification, right? So it gives you like what you should account for. But then like in practice, we have to map that information to actually estimating. So we have to bring like the causal theory into practice. And that's where I think like in the tech firms, like we are really willing to go to the next mile using causal AI, causal machine learning, to avoid making functional form, to kind of like bring this kind of like second wave of a kind of quote-unquote causal evolution.
And one thing even related to the preceding talk, tech firms being tech savvy, we love machine learning, right? Give us machine learning. We want to use technology and software, and there's a lot of computer scientists running around. Sorry, no offense to the computer scientists here. And it's interesting because some of the even simpler things we just saw in the last talk, just multiple linear regression, basic stuff, few thoughtful control variables. It's still very much in the minority. I've seen just in data science and product decision-making communities. And so I think there's still a lot of low-hanging fruit to double machine learning. It's a little bit of throw the kitchen sink, right?
Yes.
I've got thousands of variables. What do I do? Neural network. But can I carefully construct these factors, if you will, these concepts? I think there's a lot of value to that as well, and it makes sense to do both, really.
Yeah, I agree, 100%, right? So I think like one of the reasons that of this kind of like dichotomy of the two words, it is like there is this kind of bias for action. We cannot just sit for the perfect study, because like they may not exist, and just waiting for new data, waiting for like what should be done, it is like the cost of waiting is too high. So I think like what is happening these days, like we are bringing the information to the table, we're stating our assumptions, like we feel like there is uncertainty here, we are jumping from A to B, and this is only holding these statements. So I think that also like this, because the objective function of the two words is different, that explains a bit of these tools. But I mean, at the same time, there is this elephant in the room, right? Unobservables, right? So I mean, I can give you all the data in the world. There's still a lot of stuff that we wish to account for that there are unobserved confounders. So like Ibanez gave the early talk on today, combining experimental data and observational data. And the name of the game that was over there is like, well, we have these unobserved confounders that we wish to account. And that is also something that is very fascinating to see the differences between like industry applications and academia. I mean, I made a career in academia out of differences methods. And this is kind of like trying to push for like accounting for unobserved confounders that is time invariant somehow. But that's not the only game in town. I mean, in academia, in economics, discipline, that's kind of like the bread and butter for many empirical tools, right? So, I mean, there is a paper saying like out of like, I don't know, like more than 20% of NBR working papers mention differences. But when you go to the tech industry, we see that like there is a lot of emphasis, a lot of appetite for other methods that account for unobserved confounders. So Judith like also gave a talk today about synthetic controls, and that is something that is also like appearing more and more. And the dichotomy here is like, well, in academia we see a lot of, in publications, a lot of differences. In tech we see a lot of synthetic control methodology. And the beauty of these tools is that they can account for unobserved confounders, but it's not magical, right? So there is a structure, and
No, I think, look, it's interesting. Academics, and I'm a recovering academic, are paid to be clever, to be smart, to be thoughtful about how they think about data, and difference. And those who don't know the technique, it's very simple technique. I mean, maybe you can ask Pedro about it later, but it's the kind of looking for these experiments and data where the experiment itself has like elegance, right? It's beautiful. It's you can represent it in a picture. You could understand problems like what's the effect of minimum wage on the economy, and been some really, really beautiful papers written. And it's thoughtful analysis. But going to your point, tech companies, it's about speed, it's about practicality, it's about decision making, and there's just not a lot of time to meditate on.
Yeah.
And so the beauty of these other techniques, like synthetic controls, it captures similar reasoning. A synthetic control is, I have an observational unit that received a treatment. I'm trying to create the same observational unit without the treatment. I don't exactly have that same observational unit without the treatment, so I can synthesize one, right? It's sort of very, very intuitive. Something data scientists can do, something teams can build, something that can be explained to executives. And so I think one thing interesting as you go from, and I think everyone has experienced this, as you go from academics to industry, the set of things that work well in academic seminars and the set of things that work well in organizational decision making, that intersecting set is almost like it's very small.
Yeah.
And those techniques are the killer techniques, and I think distilling what those are, synthetic controls, I think in instrumental variables, I tend to think is useful. Regression. I mean, there's a lot of just basic stuff that's really helpful.
Oh yeah, I mean, I think like the key on this is to recognize and acknowledge that we live in a world that we cannot account for everything we want to.
Yeah.
I mean, like the Nobel Prize, like 2021, about instrumental variables, and that's the name of the game, right? We're looking for randomness in stuff, like what is manipulating, affecting along in the causal chain. Because, I mean, in this world, when there is selection, right? And I mean, I have the data in my hands. The decision makers, the stakeholders are asking us for new insights. Should we keep doing this program? Should we expand the program? Right? I mean, at the very early stage, you may say, well, there is too much pressing demand for us. So we say, well, what's the data that we have? Like, oh, we have this data. Oh, is it perfect answer? No. Can we account for this somehow, like unobserved confounders in one way? And I have been seeing like more and more of these techniques accounting for unobserved confounders, like being deployed at scale in real time in tech companies. That is like, it's one of the areas that I have seen that's like academic work and real life applications that are getting connected, right? So
I totally agree. I mean, it's one of the more exciting areas, and sometimes lots of buzz phrases, but heterogeneous treatment effects is one that you can reference. But I mean, when you think about using, let's say, causal measurement in a technology setting, I mean, I think there's two distinct use cases to bear in mind. One I will call online application. So literally, you have an online system. It's able to causally assess what would happen if I present this customer with this marketing treatment. And it would segment, and it would apply levers, and it would create feedback loops, and that's a system, right? That these are systems that companies are trying to understand and build. Obviously, for that kind of a system, you want techniques that are simple, robust, scalable,
and transparent,
and manageable. I think for the other application, what I'll call offline application, is you're not in software, in real-time software, but you are doing offline assessments of your business, right? This is what data science teams do. This is what analytics teams do. And even there, looking at heterogeneity, why did the causal effect of something I did in the past differ by some segments, by some groups? The most basic segment would be the value of your customer, high-value customers versus low-value customers. So if you have like an A/B test, and you find that the lift is 10%, but the lift on your low-value customers was 20%, the lift on your high-value customers was minus 1%, do you still want to proceed with the action? I think those are the really interesting business conversations to have. Most executives don't care that much about the average treatment effect, right? You could say the lift is 5.
Yeah, I agree. So like that, and so that's very cool because like even when you have a clean experimental data, you run your A/B test, everything is like super well designed, a lot of thought was processed. How I map that knowledge to decision making.
Yeah.
Right. So and that's where like observational causal inference tools has a huge say on that because like, well, I have this experiment, I know my underlying assumptions are valid. Now I want to segment my user base or like my population into different like groups And in that case, how do I do that? Right? So is there a guided way? So can you use like causal trees, like forests? Can you do segmentation? And then these two words of experimental word and observational word get together. And this is actually like moving forward, and it's very exciting to see that happening.
Super, super exciting. And I unfortunately had to miss Guido's talk in the morning, but I mean, very much a frontier area. If you have the ability to run these A/B tests, like our previous speaker mentioned, and tech companies do, we can randomize treatments. We could randomize traffic to different experiences, but you still have to get insight from that. It's not just a number. I mean, blending an A/B test with like a time series, or blending an A/B test with some kind of like a structural economic model of your environment. I still find it remarkable, like our previous speaker mentioned, how few DAGs are written. we all know, sort of there's causal structure encoded in this language. It seems like an obvious opportunity inside organizations for data scientists to speak to business stakeholders and conceptualize the DAG. There's an intuitive DAG we have in our minds, as opposed to doing it intuitively. We can do it formally now. It's 2023, and I think it's a huge opportunity area.
No, I love that idea, because for many years we have been doing like this. At least in economics, the word have divided, right? So we have like reduced form, causal inference folks. We have structural folks. But I mean, at the end of the day, the end game is the same. It's to add value. It's to improve things, to make better decision. And at the moment, very often we do have a lot of information from subject-specific knowledge. And the next thing that we should be doing it, and we're seeing this happening more, is like talk to the people who knows the systems. Talk to the people who are experts on the subject, right? Impose this structure, like up to some extent, into your model, such that the causal model it's also mimicking the concrete application, so you can get signal, you can gain power, you can move faster, right? Because if you are like, people say, oh, causal inference is kind of like, it's structure agnostic. I usually say, no, very often you're not structure agnostic, because behind the scenes, when you move from identification to estimation, you're imposing structure behind the scenes, right? So what we should be doing is be more like structure aware instead of structure blind, and get the best of the words, because at the end of the day, we are not in the faith business, right? So we have to this is reality. We have to be bringing what we know to the table, and say, well, now this is reality. We can validate our models, move on, adaptive experimentation to validate things and make better decisions.
Yeah. No, I mean, I think, all fields have factions and wars. In economics, and the types of economics that's made its way into industry, there is sometimes called the reduced form versus structuralist view of data. What we saw in the finance talk just now was often a reduced form view of economics, that we can boil the world down to a y variable and some x variables that impact the y variable. And the goal in that case is some kind of measurement, right? Measure the effect of x on y. I think there are other schools of thought that are not first and foremost focused on measurement per se, but modeling, understanding a mechanism, understanding how a complex process works. I think someone referenced biology earlier. Lots of economists view economic systems as complex systems that can be modeled and can be understood. Businesses are highly economic. There's demand functions, there's cost functions, there's equilibria, there's game theory. Bringing all of that to bear on your causal theory of reality and using data to estimate those structures, it's a very, very different kind of practice than oftentimes what you see in industry, but I think another low-hanging fruit, I think, for the field.
Yeah, but I mean, this is the kind of our ideal world, but the real challenge is to bring all these innovations in a unified language and translate this to decision makers, stakeholders, right? So if you see traditional stakeholders, they look at dashboards, raw data to make decisions, and it's still not clear how we translate all these causal tools, right? All this causal information, all these counterfactual assessments. You bring this to a meeting, and our stakeholders, in a way that they understand the language, we all on the table, they understand the notion of uncertainty that we're talking about, and I think that's what we should also be moving forward. And it's a kind of an open challenge. This is kind of a call for everybody who is here, everybody who is joining us online, to kind of like think about how we can move this, create kind of causal inference community that everybody like leverage the information. To the end game is to make better decisions.
Yeah. No, and I think we were discussing before. Lots of good executives have a causal theory of reality in their heads. So what do they oftentimes want to see is it's data. Show me metrics. Show me dashboards. Show me OKR. Show me this deluge of highly correlational data where the causal filtering is happening. Where? In a boardroom, in a meeting, in a discussion. I think the interesting challenge for this community is now that we have these tools, you don't have to do it intuitively. How do you start to reconcile that with really that very traditional mindset? So if you come out with, and we were joking before, if you have a causal model that goes in the opposite direction as the correlational model, you kind of have an uphill battle to climb in terms of convincing your decision maker that A is the way to go versus B. So I think we haven't figured that out yet, as far as I can tell.
No, I agree, and that's where like this coming up with a language. I mean, that is the whole path of like educational perspective as well, bringing these tools to the mainstream, right? Making everybody familiar, and I mean, also there is like unobserved confounders.
Yeah.
And what I wish, because I mean, whenever you see like this kind of sign flips, right, or like direction going different, results going different directions, you have to go and own it, right? And very often it's like, everybody has a backstory, or like kind of, oh, what if is this? What if is that? And often we don't have this kind of ways to quantify that in the data, because if this was feature that was in the data, we would have accounted for.
Yep.
So what I'm wishing moving forward is like we can do more sensitivity analysis type of work, right? To kind of like find a way to quantify how much like our conclusions it is actually being like guided through assumptions and how much it is not, right? So if I were to relax my assumptions, I don't know, like 5, 10, 20% in some way, would that flip my decision? And that would also help to make more robust, like put causal inference at the forefront and making more decisions, more informed decisions.
Yeah, and that's one thing beautiful. I'll say the last thing, and then we're out of time, is in a business setting, in a tech company setting, people don't expect you to have all the data. Like it's understood that the world isn't perfect and knowledge isn't perfect. So you're allowed to make assumptions, right? Assumptions are okay. It's like as long as you state it. And one great way to fill a gap in data is to make a reasonable assumption. And I think it's another highly underutilized opportunity for the field.
Yeah,
all good
with that.
Thank you very much to both of you with that. Definitely some of the items that you brought up there definitely resonated with some of my own experiences in this space. So I think that that's probably the same for a lot of the audience members here. So are there any questions for either of our panelists here?
Thanks. Well, thanks, Pedro and Amit. Really great fireside chat. So if we take learnings from the challenges that data science teams often had in making models explainable to the line of business in a correlation model, what can we take from that and learn from that specifically with how we bring causal models out to the same group of folks?
So I'll go first, then you compare.
Sure.
So what I have seen being done is like we compute this like black box model, right? But then it's like you have a customer comes, well, but why my metric is this instead of that? Right? So we have to find, we should like find a way to decompose the channels, the mechanisms, at least to summarize, to give a first order approximation of why we went from A to B, right? And what I have been seeing doing this is kind of the composition of the overall effect into mechanisms, or like using kind of like causal trees, right? So you have a decision maker, so the path of the treatment is here. Also have an underlying, like if you want to use a DAG, so the intervention was made here, then we decompose how the changes affect the whole system. That usually requires additional structure, additional assumptions. Right? So that's where like the knowledge of the subject specific helps, because that's where I think is like to have this kind of mapped out. So a customer comes, say, oh, I see this metric. Where should I interfere, right? So that's like having that kind of map out. It is the way to go.
Yeah. I mean, it's a great question. I'll tell you my little trick that I've used in a data science space, and maybe it'll apply to a causal space. It hit me like a ton of bricks at some point that, it's sort of about trust, right? This person is telling me something, or this model is telling me something. Do I trust this, right? And in academic world, we're really focused on the model, right? This beautiful structure, the DAG, the science. But in a business setting, I started to realize it's only me who cares this much about the model. Like, people around me, what do they see? They see the inputs, they see the outputs. And I think it's really important to just have that recognition that a lot of trust comes from trusting the inputs. Am I using the right inputs? Oftentimes in academics, we try to use less inputs because it's more parsimonious. It doesn't make sense in some business settings. It's just like, why would you do that? Like, why would you drop like a fundamental input that I care about? And then outputs, of course, it's really hard, right? I mean, you have to think about, it's not about tables. It could be sometimes. It really depends on the organizational setting. But I mean, certainly I think all of us are hip to this fact, like visualization is really powerful. And like, I think data viz is a really powerful field. And I think getting out of Excel line charts into something more cognitively real is still kind of an open question, I think, for the causal community. What does the output look like? But anyway, good question.
So I think it seems that we all agree that one of the big challenges is to bring causal instruments into the leadership meetings is to establish trust, like trust in this analysis. You just mentioned that we could try to do it via powerful visualization and really trying to explain, building a narrative around this. Besides this, how much do you think will also be relevant, potentially leveraging the quick iteration pace that exists in a tech company in terms of output literally per working day compared to, for example, academia, in terms of literally keep showing results and potentially using this as a learning tool also for non-technical people to slowly adapt and understand what causality means.
Yeah. I mean, look, I think it's huge. I mean, I think the ability to iterate means you don't have to be perfect. To get going, to get some data, you can be a little bit more hypothesis driven. So it's obviously huge. I think how you iterate becomes kind of key. And are you iterating like in an organizational sense, like we're going off, trying something, collecting data, coming back, assessing what happened, refining what we're doing, or are we doing it in an automated way, which is like we're going to go to market with a class of models that we know are imperfect, but these models are going to learn over time and become better. I think both are really powerful. My own experience has been organizational iteration is not nearly as quick as one might hope or imagine. So I think kind of there's these notions of the build, measure, test cycles, I think is what it's called, where we're supposed to go through these flywheels and get more intelligent over time. Really depends on the organization, how well that happens. I think there's a lot of opportunity, though, in adaptive online iteration.
Yeah, I mean, I think like adaptive experimentation, if you're able to run an A/B test, like if you have that infrastructure ready, there's a lot of push for doing this adaptive experimentation, so you learn from the past, like combining reinforcement learning with experimentation in that sense. I mean, that's one area that I'd say has been pushed. But I mean, at the end of the day, it's true. So it's like, well, what if you do not have that infrastructure, right? So I mean, I don't know, like some falsification tests, or like leveraging previous labs, right? To kind of like, well, or having very carefully defined guardrail metrics. That is, you should not suppose see like lifts where you should not sing. That is where usually I see how like we gain trust to like we are able to explain why we're getting what we're getting it.
Yeah.
Great. I think we have time for one more question here in the front of the room. Oh, in the front, perhaps?
Okay, thank you for the opportunity, and thank you for the conversation. That's very insightful. I think you mentioned about the experience in academia and also the application in the industry. So I would like to hear if you have any experience about the transition from academia to industry. Like in academia, if we find something in the causal model, we can just report it. But in the industry, any result can immediately transfer into the cost and benefit. Like something that I might quite like at work, the first time the customer come to tell me that after launching this new product, I need 50 more new employees to support the service. Then I told them, my causal model said, we do not need that. So that's the first time. And the second time, because the treatment is not one time, we roll out the services state by state. So the customer come back, ask again, I need 30 more new employees, and I see the model doesn't support that again. And then the third time, customer come back and see, is your model accurate? I still see new increase in the demand. I want new employee. And probably this time, because the situation changed, I need to adjust my model, and my model probably still sees something different, but I worry that if I still shut them down, the customer may want to buy me a one-way ticket to the moon. So for this kind of situation, what would you handle, and how would you make the model? Like, is there any method we make our causal inference model not only deal with what happened before, but also have some be proactive, some more predictive power in the future?
No, that's a great question, and that's a very hard one to answer, right? Because, I mean, I think that really depends on the infrastructure and the structure of the company as well, right? So this is like gonna be different places, like you have reacted differently. So it is true that like in academia, like we are done, like go home, write the paper, submit it, and then like in economics, after 5 years, the paper gets published, right? Or not, right? So, but in the industries, there is more interaction, right? So there is more pressure, right? So I mean, the customer is always there asking you questions, and depending on the rigidity of the company, right? There are different incentives, right? The first thing that I always think is like, well, how much do you actually trust the stability of your causal model, right? Because you train the model in one regime, right? I mean, we don't stop the clock, things are moving. And then the customer say, well, I should do this. And you say, no, you should not do it. You say, no, I'm going to do it anyway. Well, start of my life, right? So this happens a lot. So, but what we have to think about it in my way is like, well, does the regime change? Do we have the scientific evidence to still own our decisions, right? Because there is this dichotomy. Where does my job end? Does my job end on providing the scientific evidence and giving the advice and let the business decision maker call the shots? Or is my job actually to ensure they're going to like make my shot? That depends on where I am standing in the company, right? So I think it's very tricky. So Amit is much higher than I am.
We all struggle with this, but I think you'll always do better the more you own what you're building. So if you build a model and you want people to use it, I mean, you really have to try to own it. So to own it properly, my advice to you in that situation is you kind of have to define your own KPIs. Like you built this model. How do you want it? Like what does success look like? And we just heard before, it's not predictive accuracy. If you build the best causal model, it will by definition have less predictive accuracy than a forecasting model. And so I struggle with this. Like, what does success look like? And it could be some success in the data, it could be success in the business, it could be organizational success. So I think it's really being very proactive about how you want to be not measured, but how do you want these ideas to get assessed in terms of the actual business? Yeah.
Well, thank you again to Amit and Pedro. A big round of applause for them.